similar polygons. And what I want to make sure that we understand is how they work and what we do in order to set up what are called similarity statements. You heard me talk a little bit about that yesterday. Every once in a while I would come up with, when they gave us that, the proportion, I said that this is going to be very close to what a similarity statement is going to look like. Well, that's kind of what it was leading us to be able to do. If you think about the past couple of days, in 6.1 they told you what the ratios and the proportions were, solve for x. In 6.2 they gave you letters. You had to fill in the blanks to solve the proportions and to go from there. Today you're going to start with determining whether or not something is similar to be able to write out the proportions to solve for x and go from there. So all they're doing is adding one more step on top of what we've done in the past. Okay? So the new stuff is just one extra thing from stuff you've already done. It's really not that terrible. Now, what happens here is when we talk about similar polygons, I hate to use this term, but it's how we talk and describe them is very similar to how we talked about congruent figures. Congruent figures had all the corresponding angles and all the corresponding sides equal to each other. In similar polygons, only one of those things holds true. All the corresponding angles are the same, but the sides, the corresponding sides, are proportional. And that's the big idea. Similar figures, similar polygons, have congruent angles. Oh, yeah, I see. Similar figures, or polygons, corresponding angles are the same, and the corresponding sides have common proportions. That common proportion, when we simplify it out, is going to be called the what, Mr. Fontana?
Ratio?
Which is otherwise known as the?
Fraction?
No,
The scale factor.
Hey!
Thanks.
Good job.
Oh my goodness.
All right. So what happens is, it is again, it's just a matter of looking at a diagram and writing it out. Okay. It's looking at a diagram and writing it out. Oh, thanks. I say, why didn't she do it? And then I remembered. Oh, that's right. So here's what it's going to look like when we talk about, or we look at it in terms of a diagram. And like I said, it is pretty easy to set up. It is pretty easy to work with. It's just a matter of understanding how you do your correspondence. So what I want you to do is to, actually, can I just put this diagram on a clean sheet? Or you guys got it all caught up here again? All right, give me 1 sec. I'll give you a second, and we'll go from there, all right? All right, you ready?
No.
Jeez. If you weren't left-handed, we'd be a lot done faster. It's me fail English.
Actually,
That's why you're
left
not
hand,
here.
people write way faster.
I don't get it all smudged all over your hand, though.
No, Riley's injured
So,
right now.
if you take a look at these two figures, what I want you to do is to try and draw those out. It doesn't have to be an absolute perfect artistic representation or anything. What I want you to do is get an idea of how the lettering works and how the tick marks are working. When we did this in the past, we had tick marks on our sides and we had arc markings in our angles. Obviously, when we're talking about similar figures, we don't necessarily have congruent sides. We should have proportional sides. So if you think about when we did congruent triangles or congruent figures, we always labeled them with their vertices, okay? That doesn't change. It just so happens that now we're looking at labeling vertices out of what's called a quadrilateral or a polygon. This is a quadrilateral because it has 4 sides. If it had 5 sides or 6 sides, whatever, we would just call it a regular old boring polygon because we don't know what shape it is, but for any intents and purposes. So basically, what you have to do here is when you look at it, is pick a side to work with first. Now, if I were you, when I'm writing out these types of statements and things, I'm going to write them going from left to right. I'm going to start with the figure on the left, write down all those angles, and then go to the figure on the right. Because that's how I read, moving from left to right. A lot of times, scale factors are written from figure on the left to figure on the right. If it's reversed, then you'll see it, it'll say it specifically. That's kind of where reading closely is really important for this stuff. So pick an angle to start with on the one on the left, and I'm just going to say start at D. So if I say that this is quadrilateral, what's my marker? D, E, F, G. I'm just going around the diagram alphabetically. I could have picked any letter to start with. It does not matter whatsoever. It's just a matter as long as what I start with here is going to be consistent with what I start with in the next one. Okay? What I'm checking to see here is whether or not these two figures are going to be similar. Similarity has a symbol, squiggly. Are these two similar? The question mark doesn't go with it, but the single, I think it's called a tilde?
Tilde.
I just call it squiggly. So we check and see, is quadrilateral DEFG similar to the other one? Well, if I started with D on the left, it had 3 tick marks. What do I start with on the other? And I just have to go in correspondence of the other one. J, 2 tick marks, K, 1 tick mark, L, right angle, N. Now I'm halfway done with knowing whether or not these two guys are going to be similar because I know for certain that I have all of my angles matching up. Since all of my angles match up, all I have to do now is check if my sides all have the same common ratio. So here's what happens. The easiest way to do that is to first of all figure out how many sides the figure has. It was tough, I know, I was asking a lot. It has 4 sides. Write them down. So the one on the left had DE, EF, FG, and GD. How is that looking like a proof? All I'm doing is writing down the side lengths. Now, if these things are going to have, if they're going to be similar to one another, each one of the side lengths that correspond to each other is going to have the same fraction. So, side length DE matched up to, let me move this up a bit so I can see. Side length DE matched up to what 2 letters on the other one? That has to equal, what's the next one? Has to equal, has to equal, and there you go. That's the proportionality statement, if you will, if you want to say it with a fancy way. It's all the side lengths written out as fractions. Gee, what do you think you have to do next? That's it. All you do now is you put the numbers in to check and see if each one of those individual 4 fractions simplify to the exact same fraction. If it does, then the 2 figures are in fact similar. If it doesn't, they're not similar. So you write it out. DE is how much? 15 over 20. Does that equal 6 over 8? Does that equal 12 over 16? Does that equal 9 over 12? You guys remember the easy way to check all your fractions?
Yeah.
How? Calculator. That's it. All you're doing is just putting each one of those individual fractions in the calculator to check and see if it simplifies to the same thing. That's it. And some of these things are pretty quick. You could probably tell right away. 15 over 20, you divide them both by 5, you get 3/4. 6 over 8, 3/4. 12/16, 3/4. Hey, what do you think 9/12 might simplify to?
3/4.
3/4. 3/4. Sir.
Is it possible that they do look similar or not similar?
Yes.
Alright.
Yes. Because what happens if one of these was, let's say this side was a 10. If that side was a 10, do all the fractions work out to be the same? No, then they're not similar.
Okay.
So it is completely possible to have it look closely, still have the same angle measurements, but not have the same side values that would simplify. Then you would say they're not similar. So by going through all of this, these guys all have the exact same ratio of the sides. It was 3/4. This common ratio is called a scale factor. That common ratio is called the scale factor. So you think about I forget what problem it was in the homework last night. There was one of them that you had to find out, that was the basket one, where they gave you the length and the width of a rectangle, and then they gave you the length of the building. Well, the length and the width of the rectangle they give you, I think, was 15 to 10. That was the length of the rectangle. Well, if they're similar in nature, that means this simplifies to 3/2. This would have been your scale factor. You used this scale factor to figure out the missing side length given that other width, whatever number that was. Okay? That's what you do. You're going to find missing side lengths instead of just, hey, solve for x in a problem. You're going to say, hey, solve for the altitude, solve for this mid-segment, all those parts, because once you know that you have similar figures, all of the corresponding parts, they're no longer congruent, they're all similar because of the same ratios. And it's a matter of working with scale factor. And that's really all this works out to be. But the idea here is that we need to be able to take a diagram and write this out to see if it's true. That's all you have to be able to do, guys. And it's just quite literally putting it together. Sir?
So the scale factor is going to be the answer.
Yeah, it'll ask you what is the scale factor. If they're similar, what's its scale factor? And the scale factor is each one of those 4 fractions in this case, they all simplify to the same thing. That therefore is the scale factor. If one of them, and like Mr. Leon was asking, what happens if it doesn't? Then they're not similar. That's all.
So you just put
Yeah, that's all it is. That's all there is to this. Okay? So as you can see, it is what we're going to be able to do here eventually is, hey, you might not be given those values, but you know your figures are similar, and you know that much. If you know that much, then you know that that's the scale factor. You know that's the scale factor, you use this ratio to solve for x. You use this ratio, you solve for y. You use this ratio, you solve for z. That's it. You're just reusing the same ratio. That's what's called a scale factor. Okay? And we build out more of this tomorrow. I have 2 problems for you. It's on, what page? It's on 376.
Where's like homework, or can we just write it in like our note?
Put it in the homework because you're going to add to these tomorrow.
We just have 2 problems for homework, that's it?
Yeah,
For homework or right now?
for homework. Because we'll start with this. This is the homework problems. It's on page, I forgot. Thank you. Those 2 problems right there are, they're write out a similarity statement, which means you're going to verify whether or not they are similar by doing the exact same thing please be sure.
That's real sneaky.
It is, you're going to do the exact same thing we just did in the notes. That's it. 2 problems. I want you to verify, start with an angle, walk through the diagram, and then write out all the side lengths as ratios. check and see if they simplify to the same thing.
But you want us to draw it and see.
Yeah, it's not a bad idea too. All right. And like I said, we'll build more out of this tomorrow with solving for missing pieces and things. Okay. Go ahead and get started.
With 40.
That's what this is.
Yeah, 64-48.
I mean, these shoes are just ovens. They're cooking.
Oh, the movie's like,
They are some hot dogs. They're smelly from the outside of the shoe.